Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to work some theoretical or classical probability problems. So first, let's just start with the traditional balls in an urn or marbles in a jar type of problem, where we're going to pour out a certain number of balls and we'll just see what the probability is we get different colored balls. So let's start with just drawing one ball from the urn. Now, if I'm going to draw just one ball from the urn, I want to know what's the probability that we get, what's the probability we draw a red from the urn. Now, I want to encourage you when you're working these theoretical or classical probability problems to stop first before you think numbers and just think words. How would I go about drawing just one marble, drawing a red from the urn? Well, in this situation, since it's just one marble, I would have to draw a red. I'm going to write down that word. I know on this one it seems a little silly, but as we make these harder and harder, it's going to be really important that we're able to put it into words first and before we talk numbers. Then once we've kind of got our mind wrapped around what we're doing and we have the word down, then we can stop and think about the probability of that specific thing. So what is the probability I get a red from this jar? Well, remember when we're talking about the probability of something, in the denominator we have the total number of ways we could draw something. Well, the total number of ways are the total number of balls in here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 balls in the urn. So that total number comes down on the bottom. Then on top, it's the number of things that we're looking for of that event. So in this case, it's the number of reds in the urn. So there are 3 reds. So the probability that we draw a red with one draw is 3 out of 10. Let's do another. Instead of drawing a red, how about we try to draw a green or a black? So what's the probability we draw a blue or a black marble from the jar? So again, what I want to do is encourage you to first put it into words. So before we begin, I'm just going to draw out one marble, and when I'm done, I want a blue or a black. Well, if I'm going to get a blue or a black in my one draw, I could draw a blue. So maybe I draw a blue. Or maybe I didn't draw blue in my one draw. Maybe I could draw a black. So those are the 2 ways I could do it. So I'm going to say a blue, or I could draw a black. Again, I'm going to really encourage you to put it into words first. And be sure and use these conjunctions like or and, because that's going to help us when we're figuring out the probability. So here, what is the probability? Now that I've got it written down into words, now we can find the probability. So what is the probability that I get a blue on the draw? Well, again, what I do is I put the total number in my denominator, and then I look for the number of ways that I could draw a blue ball. Well, there's just 3 in there, so that 3 is my numerator. That or, remember when we're talking probability, from our probability rules lecture, tells me that I should add. So I'm going to add my probabilities. That or lets me know I'm going to be adding. Then I'm going to look for the probability that I get a black. And again, my total number goes on bottom. And then I look to see how many blacks there are in the urn. There are 4 there. Remember, with or, we should always look for any overlap to make sure, and then we have to subtract off that overlap. But in this case, blues and blacks don't have any overlap, so we're simply just adding. We add this together, add your numerator, and keep your denominator. So the probability we get a blue and a black, a blue or a black in one draw is 7 out of 10 times. So if we drew 10 different balls, we would expect to get a blue or a black 7 of those times. All right, let's do one more with one draw. And let's make this, instead of a blue or a black, let's say, what's the probability we draw blue and then a black? So I want to know that probability. Now I'm going to draw one ball out. If I'm going to draw a blue and then a black, I would have to draw a blue and then a black. But how many balls would I end up with then? I would have 2, not 1. So it's not possible for me to get a blue and then a black with just one draw. I just can't do that. So when you're doing probability, you have to think first about the situation before you start putting numbers down. So in this case, the probability that I get a blue and then a black is 0 because I'm just drawing one marble out of the urn. All right, let's switch it up a little bit. Instead now, let's draw 2 marbles from the urn. And let's say that when we draw them, we draw one, look at it, and then put it back, and then draw another one. So we're going to call that with replacement. In other words, we're going to take it out, look at it, and then put it back in. And I want to know what's the probability that on the first one, let's do the same problem. That we're drawing two balls. What's the probability I get a blue and then a black? Well, if I'm drawing from the urn, in order to get a blue and then a black, I would have to first draw the blue. Again, I'm going to write down my words first and then worry about numbers. So I'd have to draw blue. I put the blue back in. Then on the second draw, so after I've drawn a blue, and on my second draw, I'm going to draw a black. And that's the only way, the only order I can go in to get a blue and then a black. So now that I have it written down in words, now I can find that probability and look at the probability of each. So the probability I get a blue on my first draw, well again, it's 3 out of 10. The and in here tells me, or remember from our probability rules lecture, that and tells us to multiply, that we're going to multiply our probabilities there. Now I've put the blue back in, so I still have 10 in there. And the probability I get a black on the second one then is 4 out of 10. Now anytime we're multiplying, I like to simplify before I make it big. So I'm going to simplify if I can. So the 3/10 can't be simplified, but this 4/10 is the same as 2/5. So I'm just going to simplify that down to 2/5, and now I'm going to multiply that out to make it, oh wait a minute, notice here, there's a 2 on top. When I multiply fractions, I just multiply straight across. Well, there's a 2 on top here and a 10 on bottom there. So they both have a factor of 2. So 2 goes into 10 5 times. And so on top, I'm just left with 3 times 1, which is 3, and 5 times 5, which is 25. There it is in its simplest form. The probability that I get a blue and then a black is 3 out of 25 times. So if I were to draw 2 marbles with replacement, 3 of 25 times, if I did that experiment 3 times, 25 trials there, I would expect 3 of the times for me to get a blue and then a black. All right. Now, I'm just going to take out one word from this problem. Instead of saying blue and then black, I'm just going to make it blue and black. This time it's in no particular order. So I could get a blue and then a black. Or, so again, I'm going to really encourage you to use words first and think about the different ways that you can do it. Wrap your mind around what the problem's asking first and write it down in words first. So we have a blue and a black. That's one way we could do it. Or we could get the black first and then the blue, and we would still have a blue and a black. So when I don't have an order that matters, when it's not necessarily in any specific order, I have to think about the different ways I could do it. So a blue and a black, or a black and a blue. And we're going to do the probability of that. Well, we just did the probability of blue and black. We found this was 3/10 and that was 4/10. Remember that the or tells me to add. Then a black and a blue, well, the probability I get a black is 4/10. And tells me to multiply. And then the probability I get a blue is 3 out of 10. Now, when we are multiplying, I like to simplify. But anytime we're going to add, we are going to need to have common denominators in the end. So maybe we should just wait to simplify until the very end when we're having to add, because we'll want common denominators when we add. So I'm just going to go ahead and multiply. This is 12 out of 100 plus 12 out of 100, because remember, you just multiply straight across. So 3 times 4 is 12 and 10 times 10 is 100. And now I'm going to add the two fractions. So when I add fractions, I keep my denominator and add my numerators. And I'm going to go ahead and simplify now. 4 goes into both 24 and into 100. So I'm going to divide by a fancy 1 there. Divide by 4 over 4. And we get 6 out of 25. So I would expect, if I did this 25 times, 6 of them to be a blue and black in no particular order. Okay, let's do one more where we draw 2 with replacement. Let's this time draw 2 of the same color. Draw 2 of the same color. And again, the first thing we want to do is put down words. And then we can worry about putting down numbers. But first, let's just get our minds wrapped around how we could draw 2 marbles that are the same color. So I'm going to draw 2 of the same color. Well, one color could be blue. And if I draw blue on the first one, in order for me to get 2 of the same color, then I'd have to get a blue on the second one. Notice I use that word blue, and, because I have to get a blue and a blue. Or, maybe I don't get a blue on the first one. Maybe I get a red on the first one. So another way to get 2 of the same color would be to get a red and a red. Or, instead of getting a blue or a red, maybe I get a black. In which case, I would get a black and a black. And there are just 3 colors, so therefore there's just 3 different ways for me to do this particular probability. So again, putting it in words is really helpful and really important to do first. Once you have it in words, it makes finding the probability so much easier. So now I can find the probability of each. Well, I'm going to put, the probability I get a blue on the first one is 3 out of 10. And tells me to multiply. I put the blue back in, so I still have 3 blues in there and 10 total. So my probability is still 3 out of 10. Or the probability I get a red is again 3 out of 10. And I put that first one back in, so I still have 3 out of 10 in there. Or tells me to add the black, there are 4 out of 10. I put it back in, the and multiply, put it back in, and the probability I get a black on the second one is still 4 out of 10. Now, again, I'm going to have to add with the fractions, and anytime I'm adding fractions, I'm going to have a common denominator. So I'm going to wait to simplify until the very end, anytime I'm adding. So I'm just going to multiply each one. So 3 times 3 is 9. 10 times 10 is 100. Plus 3 times 3 is 9. 10 times 10 is 100. Plus 4 times 4 is 16. 10 times 10 is 100. Now I'm going to add those together. So remember, you keep your denominator. Add the top, so 9 plus 9 is 18, plus another 16 is, what, 18 and 10 is 28, plus 6 makes 34. So divide the top and the bottom by 2, and we get 17/50ths. So if we did this experiment 15 times, I would expect 15 different trials. I would expect 17 of those to have the same, 2 of the same color. All right, let's change it just a little bit. And now let's make it, instead of with replacement, let's say without replacement. So now I'm just going to do the exact same problem, but let's do it without replacement and see how that changes things. I still, though, want to find the probability that we get 2 of the same color. Oh, well, we've already done the words. That's the first thing we want to do each time, is write it down as words. And we've done that. We could get a blue and a blue, or a red and a red, or a black and a black. So changing it to without replacement did not change my words. Let's look to see if it changes the probabilities. So the probability I get a blue on the first draw is still 3 out of 10. But now I'm not going to replace it. I have this blue in my hand. Notice there are now only 9 total balls in the urn. That 9 is my denominator. And there are 2 blue balls. So that's now my numerator. The and tells me to multiply. I'm now going to add. When I look at getting a red on the first draw, well, there's 3 out of 10. But that same situation where I have this red in my hand, that means I only have 9 total balls in the urn. And there are now only 2 red ones. The and means multiply, the or is add. I look to find the probability of a black on the first one. Well, there are 4 out of 10. But once I have a black one out of the urn, then that means that there are now only 3 out of 9 there in the urn. And I'm going to go ahead and do this. Again, because I'm adding, I'm going to wait to simplify until the very end. I'm going to want a common denominator in order to add. So 3 times 2 is 6. 10 times 9 is 90. 3 times 2 is 6. 10 times 9 is 90. And this is 12 90ths. Add those together. I've got 12 plus 12, which is 24 90ths. I can go ahead and divide the top and the bottom by 6. So 6 goes into 24 4 times, and 6 goes into 90 15 times. So if I did this experiment where I drew 2 without replacement 15 different times, 4 of those times I would expect to get 2 of the same color. Let's change this and make it just a little more difficult by drawing 3 marbles. So now let's draw 3 out of the urn. And let's get 3 of the same color. So there are several ways we could do this. Actually, instead of doing that one, let's do this. Let's draw a blue. Let's get one blue, black, and a red. I want to know what's the probability that I get a blue, a black, and a red. Okay, again, before you start putting down numbers, it's really important to get your mind wrapped around what it is that we're doing and write it down with words. So I'm going to do that first. I'm just going to think about the different ways I could draw 3 balls, a blue, a black, and a red. So drawing out the balls, I could draw a blue on the first one, and a black on the second one, and a red on the third one. But this question does not tell me that I'm supposed to do a blue and then a black and then a red. So it can be done in any particular order. I can pull out 3 balls without replacement and have those 3 balls, a blue, a black, and a red. And I wouldn't have to get them in that order. So I could do it this way. I could get the, maybe I get the blue first again, but then I get the red second, and the black last. That's another way that I could have this same situation happen. Or maybe I don't get the blue first. Maybe instead I get the red one first. Let's move that down just a little bit. So if I get the red one first, then I could get the blue one next, and then the black one. So another way to get this same situation is to draw a red and a blue and a black. Notice these conjunctions in here, or and. They really help us when we are finding the probability. But the first thing we want to do is figure out all those different ways to draw what the problem tells me to. So here I've got this, but I could do this. I could get red first and then get the black and then blue. So red and black and blue. But that's not all, because I could also get the black first, and then get the blue, and then get the red. Or I could get the black first, and then the red, and then the blue. I think finally I've gotten down all the different ways to do it. Now I can check to make sure this is all the different ways, because I have 3 options on the first one, so 3. Once I've decided on a color from there, now I only have 2 colors left to choose from. So from our counting, we can say 3 on the first one times 2 on the second one times 1 choice on the third one. How many different ways are there? Well, there are a total of 6 different ways in order to draw these 3 colors. 6 different arrangements for it. And sure enough, we have 1, 2, 3, 4, 5, 6 different arrangements for it. So now that I have it down in words, now I can finally put my probability with it. But first you want to come up with all your different words first. Now it's easy. The probability of blue is still 3 out of 10. Now I have the blue in my hand, so I only have 9 left. And there are 4 blacks. And I have the blue and the black in my hand, so now I'm down to 8. And there are 3 reds. That or tells me to add. The blues, still 3 out of 10. I've taken one out, so I'm down to 9, still 3. The and tells me to multiply each time. And the blacks, I'm now down to 8, but I have 4 in there. I'm going to put in the probability for each one of these, remembering that the ors tell me to add and the multiplication, the ands tell me to multiply. I'm also remembering to count down because I'm taking one out each time. And then just counting to see how many of each color ball there are. And the ors tell me to add, while the ands tell me to multiply. Now it's just a matter of doing the arithmetic. 4 out of 10, 3 out of 9, and 3 out of 8. So do a little, oh, notice something. Notice how on top, for all 6 choices, I have the same numbers. I have 3 times 4 times 3. This is the same thing, it's just in a different order. So, 3 times 4 is 12, times 3 is 36. 3 times 3 is 9, times 4 is also 36. No matter what order they're in, that top part is going to be 36. So all of them have a top part of 36. On bottom, there's 10 times 9 times 8 on every single one of them. So 10 times 9 times 8 is 90, times 8 is 720. Instead of adding 36 over 720 6 times, I could just take that and multiply it times 6, because there are 6 of them, to find that out. Now, I could do a little bit of simplification here. 6 goes into 720. Well, it goes into 7 one time with 1 left over. It goes into 12 2 times with 0 left over, and then it goes into 0 0 times. So when I multiply 6 times 36 over 720, I get 36 over 120. I can divide the top and bottom, well, by 12 over 12, a fancy 1 there, 12 over 12. 12 goes into 36 3 times, and 12 goes into 120 10 times. So it turns out that the probability that I get a blue and a black and a red in 3 draws without replacement is going to be 3 out of every 10 trials, or we would expect it to be 3 out of 10 trials. Okay, big deal when we're dealing with the classical or theoretical probability is first thing we want to do is write down the words. Once we have the words written down, then you can add the probability to it. We're going to look at a few random walk problems. So here we have Christopher Walken. And he's in a hotel a lot. And so when he's trying to exercise in the hotel, what he does is he goes to the stairwell and he just randomly picks some stair to start on. In this case, he started at the 2nd step. Then he just walks up and down steps randomly until he hits either the well or the landing. And the minute he reaches the landing, or he reaches the well, he's done with his exercise for the day, or for that exercise session. And somebody watched him at some point and found out that the probability that he goes up is 30%. It's always a 30% chance that he's going to take a step up. But it's a 70% chance that he's going to go down with his step. And that just is always true when he's walking up and down randomly. So I want to know, for this particular problem, what is the probability that he makes it to the well in exactly 4 steps? So the first thing we do when we're working these classical or theoretical problems is we put the problem into words. Before you start using numbers, the first thing you need to do is think about, what does the scenario look like? How can I put this into words? So Christopher Walken here, in order for him to make it to the well in 4 steps, what he would have to do is take a step down, and take another step down, and take another step down, and take another step down. So he would have to go down and down and down and down to get to the well in 4 steps. So I'm just going to write down those words first. So down and down and down and down. And really, when we're solving probability problems, the first thing we should do is just write down the words that go along. Like, how could I do this situation? Then putting the probability with it is nice and easy. So now that I have my words written down, now I can add the probabilities and find that probability. So the probability that he goes down is 70% every time. So I'm going to write 70%. I like to write my percents as fractions. So I'm going to write that 70% as 70 over 100. When dealing with probability, when I see the word and, I think of multiplication. So I'm going to multiply there. So then 70% that he goes down again, and another 70% that he goes down again, and 70% that he goes down that last time. Now, since there's no addition in here, I'm just multiplying. I'm going to go ahead and simplify before I multiply, just to make it easier numbers there. I'm going to divide the top and the bottom by 10. You know, I'm dividing by a fancy 1, 10 over 10. And so each one of those is just equal to 7/10. So I've got 7/10 times 7/10 times 7/10 times 7/10. Which on bottom, that's nice and easy to multiply by. You've got 10 times 10 times 10 times 10. I'm going to end up with 4 zeros and a 1 out front, 10,000 there. And then on top, I'm multiplying 7 times 7, which gives me 49, times another 7 times 7 is 49. So 49 times 49 is 2,401. So the probability that Christopher Walken goes down and gets to the well in just 4 steps is 2,401 out of 10,000 times. So let's just change this up just a little bit. And instead of going to the well in 4 steps, let's now make this the landing in 4 steps. So, you know, what is the probability that he then gets to the landing in 4 steps? Well, now our situation has changed. We're no longer just going to go down and down and down. Instead, we have to again put it into words. Decide how can he make it to the landing in just 4 steps. So let's look at it. Well, he could go up, but if he goes up again, he's at the landing and he's done. So he just made it to the landing in 2 steps. We want him to get 4 steps in this exercise. So going to the landing in 2 steps doesn't cut it. So instead, if he goes up, then in order to get to 4 steps, he'd have to go back down and then back up and back up again. So to get the 4 steps in, he would have to go up and down and up and up. Let me write those words down. So he goes up and down and up and up. Now, is that the only way he can make it to the landing? Let's see. What if he went down first? Can he still make it to the landing in 4 steps total? Well, let's see if he can. If he goes down, then goes up and up and up, sure enough, that gives him 4 as well. So there are 2 different ways that he can make it to the landing. Up and down and up is one way. Or another way he could do it is to go down and up and up and up. If he tried to go down twice, though, down and up, oh, he doesn't make it to the well in time. So there are 2 different possible ways for him to get to the landing in 4 steps. Now that we've found the different ways and we've thought about with words how we can come up with the ways for him to get to the landing in 4 steps, now we can add the probabilities in. I want to encourage you to first write it down in words and then add the probabilities to it afterwards. So now when we're looking at the probability he goes up, well, it's a 30% chance that it goes up. I'm going to go ahead and reduce that 30 out of 100 and just make it 3/10. You know, 30% is the same as 30 out of 100 or 3/10. And when I'm doing probability, makes me think multiply. Down is 70%. We just saw in that last problem that 70% is the same as 7/10. And makes me multiply. Up is 3/10 and up is 3/10. This or, when I'm thinking about probability, or reminds me to add and then look for any overlap. In this case, going up and down have no overlap, so I don't have to worry about the overlap part. So I'm just adding. Then I'm going to look for the probability of each piece again. So down is 7/10, and up is 3/10, and up is 3/10, and up is 3/10. So by having it written down in words, then it just helps me to realize that here I'm supposed to be adding and there I'm supposed to be multiplying. It makes it easy for me to find those different probabilities. Now it's just a simple task of doing some simple arithmetic. I've got on the bottom here 4 zeros, or 10,000. And on top I've got 21 times 9, which is 189. Here, notice that this is the same as that. The numbers on top are the same. They're in a different order, but they're the same numbers. So I end up with that same 10,000 and that same 189. So I'm just adding that twice. So I could add it together twice and say that is, that's equal to, let's see, 378 over 10,000, and then reduce from there. Or another way to think of this is just to do 2 times that 189 over 10,000. And then I can simplify ahead of time. So notice this 2 goes into that 10,000 5,000 times. So if I were to reduce this, I would get the same thing. I'd get 189 over 5,000. You know, divide the top by 2 and divide the bottom by 2, so that I end up with that same thing. So the chance that he ends up at the landing in 4 steps is 189 out of 5,000 times. So if I wanted to know what's the probability that his exercise would be done in 4 steps, well, his exercise to be done in 4 steps, he would have to make it to the landing or to the well. So what's the probability he makes it to the landing or the well in 4 steps? Well, this is the probability he makes it to the landing. And we found a second ago that the probability that he makes it to the well is, so to the well, that probability was equal to 2,401 over 10,000. So if I wanted to find out the probability he ends his exercise in 4 steps, I'd have to find this probability of landing or well. So I would take and add those together. Now I need a common denominator when I'm adding. So landing plus well would give me the probability that his exercise is done in just 4 steps. So there's our landing plus our well. So the probability his exercise is done in just 4 steps. You keep your denominator when you're adding fractions, and then you just add your numerators. So there's the probability that his exercise is done, exercise finished in 4 steps. Okay, let's change it up just a little bit. What about if he wants to work out for 6 steps and he wants to make it to the well in 6 steps? Then how could he make it to the well in 6 steps. Again, the best way to do this is to decide first in words how we're going to make it to the well in 6 steps. So let's do a little figuring here. So if he's going to make it to the well in 6 steps, if I go 1, down, and down, and down, and if he goes down again, he's done. So we didn't make it in 6, we only made it in 4. So once he's made it down 3 steps, he's got to go back up before he can go down again. So he goes up 1, and then he can go down, and there he is in the well in 6 steps. So one way to do it is to go down, and down, and down, and up, and down, and down. I'm going to use symbols this time to tell me that down, but I'm going to write it, these are my words here. So down, and down, and down, and then he has to go back up, and down, and down. So let's make sure that's 6 steps. 1, 2, 3, 4, 5, 6. Now, is that the only way he can make it? Well, what about if he went down, and then back up, and down, and down, and down? That would give me 6 steps. So that's another way to do it. So, or he could go down and down, just go down twice this time, 1, 2, and then go back up, and then down, 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 and down, and down. And again, I'm saying that and in between each one of those, so I'm going to write the word and in between each one of those. Is that all of the ways? Well, what about if he just goes down 1 spot? Let's try just going down once. So, or what if he just goes down once and then goes back up and then goes down and down and down and down? Oh, that's 6 steps also. So that's another way that he could make it to the well in 6 steps. Is that all of them? Let's try, what if he goes up first? Let's see if he goes up first, can he make it down? So up and down and down and down and down and down. Oh, that's another way that he can do it in 6 steps, make it down to the well. What about if he goes up 2 steps? Let's try that. Well, 1, 2, oh, he's at the landing. So that doesn't work either. So these are all the different ways, or this way, are all the different ways that he can make it to the well in 6 steps. Once you have it in words, then finding the probability is a lot easier. But I really want you first to think about it in words before you try to put down the numbers. Now that we have the words though, now we just add the numbers. So you got 7 tenths times 7 tenths times 7 tenths times 3 tenths times 7 tenths times 7 tenths. And each one of these ands just reminds me that that with probability, I'm thinking multiplication. Whereas the ors remind me that I'm going to add. So, and here I have the same thing, 7 tenths, 7 tenths, 3 tenths, 7 tenths, 7 tenths, 7 tenths. That or tells me to add 7 tenths times 3 tenths times 7 tenths times 7 tenths times 7 tenths times 7 tenths. I'm going to add, and then I have 3 tenths times 7 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 tenths. Now what I want you to notice is on each one of these on top, I have 1, 2, 3, 4, 5 7s and a 3 on every one of them. And when I'm multiplying, that order that they're in, multiplication is commutative, so the order doesn't really matter there. It's going to end up with the same number. So when I multiply every one of these, I'm going to end up with that same number each time, the 50 This is going to be 50,421 on top. And on bottom, when I multiply, I end up with 1, 2, 3, 4, 5, 6 zeros. So for each one of these, the chance that he makes it down to the well in 6 steps this way is 50,421. And this, when I multiply this out, it's going to be the same thing. And when I multiply this one out, it's the same thing. But I need to add them all together. Well, instead of multiplying them each one and adding them together, what I can do is just say, hey, I've got 4 of these. And I can just multiply, instead of adding this 4 times and then simplifying, I can just multiply all 4, one of them by 4. So I could add them and then simplify, or I could just take this and multiply by 4, because that's the same thing as adding them over and over again. So let's just do that. Let's just multiply by 4. Well, if we do that, 4 goes into 1,000,000, 5,000 times, so 25,000 times. Well, I think I left off a 0. Let's see, it goes into 10 2 times with 2 left over. It goes into 25 times, a 0, and then 3 zeros back there. So 250,000. So the probability that he makes it to the well in 6 steps, all those different ways are possible. The probability is 50,421 over 250,000 times. So when you are dealing with theoretical or classical probability, the idea is first you want to think about it in words. What are the different ways that I can get to that point? Write it down using those conjunctions of and or to help you out so that when you get ready to put down the probability, it just makes it that much easier for you. In this video, we're going to do another example of a classical or theoretical probability problem. So here, 3 people each roll a 6-sided die. So person 1 rolls a die, person 2 rolls a die, and person 3 rolls a die. Then all 3 dice are added. So maybe that one rolled a 1, and this one rolled a 2, and that one rolled a 3. You just add them together. 1 plus 2 is 3, plus 3 makes 6. I want to know, what is the probability the dice sum to 3? So when we add all 3 of the dice together, what's the probability that we get a sum of 3? So when we work these classical or theoretical probability problems, the first thing we want to do is write down in words how we would go about getting whatever it is that we're looking for. So in this case, our event is that they sum to 3. So we have to think about what would they roll so that when they all sum together, they add up to be 3. Well, in order for that to happen, each person would have to roll a 1. So in words, I'm going to write and just write how they would go about getting that 3. So they would have to roll, the first person would have to roll a 1, and the second person would have to roll a 1, and the third person would have to roll a 1. So we would have to roll a 1 and a 1 and a 1. Once you have the how to do it in words, then it makes finding the probability of each thing a little bit easier. So now I can find the probability that each person rolls a 1. So the probability that this person rolls a 1 is 1 out of 6, because there's 6 sides on a die, and there's 1 on that 6-sided die. This and because they're independent, we're going to multiply these together. So that and reminds me I'm multiplying. The probability the second person rolls a 1 is also 1 out of 6. And then the probability the third person rolls a 1 is also 1 out of 6. So the probability that they roll a 1 and a 1 and a 1 is 1 out of 216. Let's take that same idea And now let's just change our sum to be 18. Now again, what we have to do first is figure out how they could go about rolling a sum of 18. What would each person have to roll in order for, when they add them together, the sum to add up to be 18? Well, if the first one rolls a 1, that would mean the other two would have to roll 17 between them. But 6 plus 6 just makes 12. So they can't roll a 17 between them. In fact, if you look at that 18 and you divide it amongst all three of them, they could all each roll 6 in order to get to 18. So let's just start there. So a 6 and a 6 and a 6. And that's, anybody rolls anything lower than a 6, then the other two won't have enough to get to 18. So this is the only way we can get to 18 is to roll a 6 and a 6 and a 6. And again, we want to put this in words first to help us with the probability. So then once we have it in words, then we can go back and put the probabilities with it. What's the probability the first one rolls a 6? It's 1 out of 6. And tells me to multiply. What's the probability the second one rolls a 6? It's 1 out of 6. And the third one. And so the probability that they roll an 18 is the same as the probability of them rolling a 3. It's 1 out of 216. Let's make it a little bit trickier. What about if we wanted a sum of 4? Let's look and see how could we get a sum of 4. So in this case, if they're going to sum to 4, and the first person, dividing that by 3, well, we've got 1, 1, and then a little bit. So we're going to have a little bit left over. So dividing that up, we're going to have somebody roll something different. So if the first person rolls a 1, and the second person rolls a 1, then the third person, in order to get up to 4, would have to roll a 2. So that's one way they could get a sum of 4. But they could do it another way. Because in this case, the last person rolled a 2. But maybe, instead of the last person rolling a 2, maybe the first person rolls a 2. So maybe they do a 2, and then if that one rolls a 2, there's only 2 left. So that means each one of them has to roll 1. Or maybe this middle guy rolls a 2. So there's a third way. The first one could roll a 1, and the second one could roll a 2, and the third one could roll a 1. Now, everybody had a chance to roll that 2, while the other 2 rolled 1s. And 2 plus 1 is the only way we can get to 4. Now that we have written down all the different ways that we can get to 4, now we can go back and put in the probabilities. So the probability you roll any one particular number on a die is 1 out of 6. Then the ands, I'm going to multiply. The ors tell me to add. So I'm just putting 1/6 for each of those probabilities. The probability this guy rolls a 2, the probability this guy rolls a 1, and the ands tell me to multiply, and the ors tell me to add. Then 1/6 times 1/6 times 1/6. Now we've already seen that 1/6 times 1/6 times 1/6 is 1 out of 216. So notice that all three of these are the same. So we could take and say, well, this one's 1 out of 216, plus this one's 1 out of 216, plus this one's 1 out of 216, and then add them together to get 3 out of 216. Or we could simply say let's just multiply it. There are 3 different ways to come about this problem. And we know the probability for each one of them is 1 out of 216. So we could just multiply 3 times 216. Now remember, we just multiply straight across, so you get 3 out of 216. But I like to simplify before I multiply, instead of simplifying afterwards. So I'm going to divide the top and bottom by 3, or this 3 goes into that 216. Well, 3 goes into 21 7 times, and 3 goes into 6 2 times. And I still have that 1 left over. So 1 out of every 72 times the 3 people roll it, I would expect them to get a sum of 4. Let's do a really tricky one. Let's sum it to 6. So again, we're going to find all the different ways that we can sum to 6. And the first thing we want to do is put it into words. That's the first thing we want to do. So we've got to come up with all those different possibilities, all the different ways that we can sum to 6. I'm going to use my first trick and just take it and divide it by 3 people, so that if they got an even amount, how much would they each have to roll? So one could roll a 2 and a 2 and a 2. And that would add up to 6, because 2 plus 2 plus 2 adds up to 6. That's one way they could get a sum of 6. But just like before, we could do it in some other ways. Maybe one of them rolls a 1. So let's see what happens if one of them rolls a 1. So if one of them rolls a 1, and the second one also rolls a 1, then that third one would need to roll a 4 so that they summed to 6. Now, it could be the third person that rolled the 4, but it could also be the second person, or it could be the first person. So there are actually 3 different possible ways for us to get this 1 and 1 and 4, to get 2 1s and a 4. So that's 1, but then the first person could, or the second person could. So far we have 1, 2, 3, 4 different ways for us to get a sum of 6. Then what about here? We said the first one rolled a 1, but what if the second one, instead of rolling a 1, rolled a 2? Then that would mean the third one would need to roll a 3. So we have a 1 and a 2 and a 3. But maybe they do it in the opposite order. Maybe he still rolls a 1, but the second one rolls a 3 and the third one rolls a 2. So that's another way that they could get a sum of 6. Or maybe it's not the first one that rolls the 1. Maybe the second one rolls the 1. Well, if the second guy rolls a 1, then the first guy could roll the 2, and the last guy could roll the 3. Or, if the second one rolls the 1, the first one could roll the 3, and the last guy could roll the 2. Or, so far the first one's rolled the 1, the second one rolls the 1. Let's see if the third one rolled the 1. Then the first one could roll the 2, and the second one could roll the 3. Or, the last one still rolling that 1, the first one could roll a 3, and the second one roll a 2. So now, let's think about if there's any other way. Let's think about if the first one rolls a 1 and the second one rolls a 3, well, 1 plus 3 makes 4, then the last one would have to roll a 2. Oh, we already have that scenario there. So it turns out that we can't roll any other combination of 6. These are all the different ways that they could sum to be 6. let's look and see how many different ways there were. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total different ways for us to get a sum of 6. So now what we're going to do is find the probability of each of those. Well, we know to find the probability of one number in a particular die is just 1 out of 6. And that's going to be true for each one of these, that it's going to be 1/6, 1/6, 1/6 for all 10 of those. And the ands tell us to multiply. So we're just going to be multiplying on all 10 of these, 1/6 times 1/6 times 1/6. So each individual possibility here, the probability is 1 out of 216. But then the ORs tell us that we're going to add them all together. So we're going to add together all 10 of those 216s. Instead of adding 1 over 216 over and over again, we can just multiply 10 times that 1 over 216. You can just multiply straight across, so you get 10 over 216. I could do it that way this time. Normally, I like to simplify before I multiply, but remember with fractions, we're just multiplying straight across. And then we'll need to reduce. So 2 goes into the top and into the bottom. So the probability that we get a sum of 6 is 5 over 108. So out of every 108 times that our 3 people roll their dice, we would expect 5 of those to be a sum of 6. So first, think about all the different ways that you can come up with your outcome, and then put it into words using those words and or to help out before you finally put in the probability. Thanks for watching.